All right, this is the section 2.1 notes. We had two other examples that we didn't get to in class that I want to make sure I include on the video because we will be starting in section 2.2 next time. So there's this example right here. This is on the same page as the definition of the derivative, which is kind of in the middle of the page. So it says section 2.1, we want to find the slope of the graph of f of x equals x squared at the point negative 3, 9. Because we're asking for the slope of a graph at a specific point, that means we're doing the tangent slope, which means we want to use that difference quotient and let the limit as delta x approach 0. The second part, so that's the first part, we just need to find that slope. The second portion is that we need to then find the equation of the tangent line. So that means we'll have to do something and get it in y equals mx plus b form. Okay, so for this one, our goal is going to be to take the limit as delta x approaches 0 of the difference quotient, which we have written down, but I don't want to write it all here, and then evaluate it at the x value of the point, which is negative 3. So let's go through the steps. So the first thing is we want to do the limit as delta x approaches 0. Remember, this equals our slope of our tangent line of f of x plus delta x minus f of x all over delta x. So we have to use this formula for our f. So this would be equals the limit as delta x approaches 0 of, since it's just x squared, it's going to be x plus delta x squared for the first evaluation, and then just minus x squared for the second evaluation. So it's not too bad. So all over delta x, we need to FOIL out the top. So that would be x squared plus 2x delta x plus delta x squared minus x squared all over delta x. That's just FOILing this out by writing it twice and multiplying, and then we have our minus x squared. And then this would equal the limit as delta x approaches 0. The x squareds are going to cancel out on top, so it's just going to be 2x delta x plus delta x squared all over delta x. Notice I haven't dropped off my limit yet because I'm still dividing by 0 if I were to plug it in right now. But as soon as we do this next step, we'll be able to evaluate. So we can cancel out the delta x's that match on top and bottom. So this is 2x plus delta x. And now we no longer have the delta x in the denominator, so we can do 2x plus the evaluation at 0. So this is just 2x. Now, this is the slope of a tangent line, but we want the slope of the tangent line at a specific point. So we're going to plug in the negative 3, and the slope that we're looking for our equation is negative 6. So then the last part is something we did in the previous units. It's just how do you find the equation of a line? Specifically, this is the tangent line. Well, we use point slope, so this is part 2. This was part 1. And we use y minus y1 equals m parentheses x minus x1. We do have our point, and we have our slope now. So y minus 9 equals negative 6 parentheses x minus a negative 3, so that'll be plus 3. We would distribute that negative 6 and then add over the 9. So the equation of the tangent line, and that would still be negative, is negative 6x minus 9 equals y. So this was part 1. Here's the slope of the tangent at that specific point. And part 2 is the tangent line equation. Now, the only other one that we didn't get to in section 2.1 was another fraction one, because I did some of these as a recording so that you guys could watch more examples at home, because I find that that is more helpful for students. We did one fraction together in class, so let's do another one. So this is 1 over t plus 3. So we're trying to, and now just to review this definition, and this was in the pre-video, it says the derivative of a function f at x is given by f prime of x, that's its notation, and that is equal to the limit as delta x goes to 0 of the difference quotient. So in other words, we're saying the derivative of a function at x, the first derivative, is equal to the slope of the tangent at that specific point. So since we don't always have a specific point given to us, we usually have it written in terms of x's. So let's look at this one with the 1 over t plus 3. So the way I'm going to write this out is I have to write that this is h prime of t, and that is way too big, equals And then remember we have our limit as delta t, since this is a t this time, goes to 0 of, and then remember it's going to be plug in a t plus delta t on the first part, so it's going to be 1 over t plus delta t, where the t used to be, plus 3, minus just the exact fraction that we have, but we're subtracting it, so this is like f of t minus f of t. And that doesn't change anything right now since they're two separate fractions, and then all over delta t. So we need to get a common denominator here. This one is actually a trinomial because there's 3 terms in the bottom, and this is a binomial, so they're not matching. So you just multiply each denominator by the other one. So if I multiply the first fraction by the other denominator, I would get a t plus 3 on top over my common denominator of t plus 3, t plus delta t plus 3. So there's the first fraction now with a common denominator, minus the second one would have everything from this one. So it's going to be a t plus delta t plus 3 over t plus 3 times t plus delta t plus 3. So all I did right now is just get a common denominator. And then I have my delta t in the bottom. So my next step is going to be to add or subtract essentially these like terms. Now you do have to remember to distribute that negative to all 3 terms because it's subtraction. So this next line would be that the limit of delta t approaching 0, and I'm going to go ahead and save some steps since this is not a lot of room to write. The t will be minus t, so that's going to cancel. The 3 will be a minus 3 over here, so it's going to cancel. So all we have is really a negative delta t. That's what's going to be left. And since we added the fractions together, we have our denominator that they had in common on the bottom. And then I like to write this guy as delta t over 1 for my next step. So what I'm going to do is I have a fraction over a fraction, so I'm going to multiply by the reciprocal. So that would be the first fraction, t plus 3, t plus delta t plus 3. And this is now times 1 over delta t. The nice thing about that is the delta t's cancel. I haven't evaluated yet, so I'm still writing my limit. And then now I have negative 1 over a t plus 3 and a t plus delta t plus 3. Ran out of room right there. So notice this delta t going in for 0 here is okay because it would still be a t plus 3. It doesn't zero out the whole fraction down there, the denominator. So I can evaluate and I get negative 1 over t plus 3 and then another t plus 3 once the delta t is a 0. So a better way of writing that would be that h prime of t is negative 1 over t plus 3 squared. So there's my derivative for that one. Okay, so that finishes up section 2.1, and now I'm going to go do some of the pre-videos for next week, and that way we will be on track.